Okay, today we are going to study about the AC current or voltage which is flowing through a resistance or inductance or capacitance. Okay, what will be the response? We are going to consider the phase angle introduced between the voltage applied and the current when current flows through this either through resistor, inductors or capacitor only. We are considering in one circuit either resistor only or inductance only or capacitance only. Okay, so നമ്മളൊരു ഇൻഡക്ടറിലൂടെയോ റെസിസ്റ്ററിലൂടെയോ കപ്പാസിറ്ററിലൂടെയോ വോൾട്ടേജ് അപ്ലൈ ചെയ്യുമ്പോൾ അവിടെ ഉണ്ടാവുന്ന കറണ്ട് വോൾട്ടേജും കറണ്ടും തമ്മിലുള്ള റിലേഷൻഷിപ്പ് ഒന്ന് നോക്കാം. What will be the response? So in each case we will assume that we are given an alternating voltage of equation V of t is equal to Vm sin omega t. Okay. So now first we are going to consider AC flowing through pure ohmic resistance alone or a phase relation in a pure resistor. Okay. So first we consider this diagram. Just consider resistor having resistance value R and we are applying a voltage V of t. V of t is equal to Vm sin omega t. Okay. And the current flowing through is I. So first we are going to find out how the phase difference between or phase angle between voltage and current in a pure resistor alone. So the circuit shown have only one resistor. There is only resistance, ohmic resistance R only. Okay, R is the ohmic resistance and I is the current flowing through, instantaneous current. I of t is the instantaneous current flowing through that resistor. What will be the equation according to Ohm's law? What will be the voltage equation? V of t is equal to I of t into R. We can write it as IR. V is equal to IR by Ohm's law. So voltage equation is V of t is equal to I of t into R. So by putting the value of voltage equation, V of t equation, what happens? V of t is equal to, we know that it is, here I will write Vm sin omega t. Vm sin omega t equal to I of t into R. Okay. So from this you can find out I of t is equal to R by I of t is equal to, not R, take R to this side. So Vm by R into sin omega t. Then Vm by R. Im is equal to, so the maximum value of current we can take Im is equal to Vm by R. Okay. So current I is at maximum when sin omega t is unity. This value become unity, then maximum current Im will be Vm by R. So it becomes I of t is equal to Im sin omega t. I of t is equal to Im sin omega t. Okay, Im sin omega t. Vm by R nu parayunnathu Im aanallo. So Im sin omega t annathu. Okay. So comparing the first equation, this one is the first equation and this one is second equation. Comparing these two equations, we can see that both the angle is same, sin omega t. That means voltage and current are in phase with each other. So we can draw the waveforms like that. Voltage wave and current wave in a pure resistor will be in phase. So the voltage wave and current wave we can draw. This will be the voltage wave. That is V is equal to V of t is equal to Vm sin omega t. And this one is current waveform. The magnitude will be different for I, that is I of t. I of t is equal to Im sin omega t. This will be voltage and current relation in a pure resistor. That is, the voltage and current are in phase. And the instantaneous value of power, will be V into I, or we can write it as Vm sin omega t into Im sin omega t, that is Vm Im sin square omega t എന്ന് പറയാം അല്ലേ. So we can write it as sin square omega t in terms of cos, that is Vm, we can write this as Vm Im 1 minus cos 2 omega t by 2. So we can write it as Vm Im by 2 into 1 minus cos 2 omega t. Okay. So we can write it as, split this into two terms, Vm Im by 2 minus Vm Im by 2 into cos 2 omega t. Okay. So when we considering that this term, first part is a constant part. Okay. So the power consists of constant part Vm Im by 2 and a fluctuating part. This is a fluctuating part Vm Im cos by 2 cos 2 omega t of frequency. So for a complete cycle, this term becomes 0. So we can write it as the instantaneous value power for a whole cycle P is equal to Vm Im by 2 എന്ന് എഴുതാം. Okay. For a whole cycle we can eliminate this term. So Vm Im by 2 ആയിരിക്കും power. Okay. So this is the, now we represent this as a waveform. This waveform, voltage and current relationship as a waveform, we can represent it as a phasor diagram. We know that these are same, voltage and current are in same phase or in phase. So we can reference, V is taken as reference, and the current vector is also in phase with it. So we can draw V and I are in phase with the diagram. So phasor representation, phasor diagram എന്ന് പറയുമ്പോൾ നമ്മൾ ഇങ്ങനെയാണ് വരയ്ക്കേണ്ടത്, vectors ആയിട്ട്. Okay. Phasor diagram representation of voltage and current relationship in a pure resistance circuit. Okay. So now we are going to consider a voltage and current relationship in an inductor. Inductor means it's a coil. So when a coil is connected across a voltage V of t is equal to Vm sin omega t. Now we are going to consider a coil, a pure inductive coil. So there is no resistance. Actually, pure inductive coil means that it has no ohmic resistance. അതായത് I square R loss ഇല്ല, just a coil. So inductance property L ആണ് ഇവിടെ മെയിൻ ആയിട്ട് വരുന്നത്. So there is no I square R loss. Pure inductance is actually not practically possible. There will be some resistance. So it is very nearly approached by coil bound with a such thick wire, that is where resistance is negligible. So such a wire is connected here, winding. Okay. So this is a coil. Okay. So when an alternating voltage is applied to a pure inductive coil, what happens? An EMF will be induced due to self-inductance L. Okay. Or EMF produced. So this EMF opposes the change in current through it. That is the property of inductive coil. So as there is no resistive drop, voltage drop, the applied voltage equation, we know that we taken V is equal to V of t is taken as Vm sin omega t. Okay. Then we can represent the voltage equation in inductor as the self-inductance into rate of change of current, di by dt. Okay. Di by dt. So we can write it as this equation as substitute for V, that is this equation V of t is equal to Vm sin omega t. Vm sin omega t is equal to L into di by dt. We have to find out the current I, equation for current I of t. So take it as di is equal to, what is Vm by L into sin omega t dt. Sin omega t dt. So di To find out I, integrate both sides. Integrating both sides, we will get I of t. I of t is equal to integral. Vm by L is constant, so take it as outside. Vm by L integral sine omega t dt. Okay, so I of t is equal to sine omega t integrate we have studied in maths. It is integral sine omega t is minus cos omega t by omega. So Vm by omega it's constant 2 pi f. So V by L omega into minus cos omega t. Okay. So this is a constant. L and omega is a constant integration. So L omega we can write it as inductive reactance as L omega is equal to XL. Sorry, X suffix L. Represent L omega is equal to XL, that is inductive reactance. So we can write it as Im is equal to Vm by omega L. The maximum value of current is Vm by omega L or L omega, that is Vm by XL. Okay, Vm by XL is the maximum current. So when will be the maximum current is possible? This term become unity. When the term become unity, then only this current is possible. So minus cos omega t, we know that we have to represent this current in a sine as a sinusoidal waveform. So you have to represent the same equation. I of t is equal to Im that means Im by Vm by XL minus cos omega t. Minus cos omega t. You have to represent this cos omega t in terms of sine. Well, how can you represent minus cos omega t in terms of sine? Sine omega t minus pi by 2. So we can represent it as Im sine omega t minus pi by 2. Okay, that means minus 90 degree. Hence, this equation of current becomes I of t is equal to Im sin omega t minus pi by 2. From this, you can find that if the applied voltage is represented, then the equation you consider a voltage V of t is equal to Vm sin omega t. Then I of t is equal to Im sin omega t minus pi by 2. So you can find out this angular difference here. One reference is taken as omega t, then minus pi by 2 means it is lagging current. So in a pure inductive circuit, current is lagging by an angle pi by 2. Okay, so pure inductive circuit in which current lags behind the applied voltage by a 90 degree. So phase difference between these two are pi by 2. Voltage is the leading voltage. So we can represent the waveform. That is, we taken the voltage as the reference wave. This is V of t. And now current. In pure resistive circuit, we shown that it is started from the origin itself. But here it is started by lagging by pi by 2. So by an angle pi by 2, the current vector is lagging. So the waveform of current will be like this. So this is I of t. Okay. So current vector is like this. And we can represent this as a phasor diagram. As a waveform we have represented like this. Now phasor diagram of pure inductive voltage and current relationship is, first voltage is taken as V of t. V of t is taken as reference. We know that lagging wave is represented in clockwise direction. So the current vector represents 90 degree lagging by this vector. voltage vector, that is I of t. So phasor diagram is represented like this. Voltage waveform, the reference is taken on x-axis and current is taken in 90-degree lagging by the voltage by applied voltage. Okay, so this is the waveform representation and phasor diagram of a pure inductive circuit. And here the inductive reactance XL is found that self-inductance into angular frequency omega, that is L into 2 pi f. You can find out the inductive reactance as L into 2 pi f. Okay, and the impedance of this circuit is taken as voltage by impedance can be find out by the ratio of voltage by current. So V of t by I of t. Okay, so you can write it as XL in terms of maximum value, Zm as XL into Im divided by Im. Maximum value of current is Im. So we can take the Z as for a pure inductive circuit, impedance is XL. Okay, impedance is XL. Okay, and the power in this circuit, so instantaneous power, you can instantaneous power may be Vm Im sin omega t into sin omega t minus pi by 2, but Vi power is equal to, you know that V of t into I of t. So by substituting the value of these equations of V of t and I of t, but by considering the power for a whole cycle, for a pure inductive circuit, power for whole cycle, it is equal to 0. Average value is equal to 0 because sin omega t is coming there for a full sinusoidal wave, for whole power is equal to 0. But the maximum value of instantaneous power is taken as P is equal to Vm Im by 2. Okay, so the maximum value or instantaneous value is taken as Vm Im by 2. So for a whole cycle, the total power for a pure inductive circuit is 0. Okay, for pure resistive circuit it is Vm Im by 2. For pure inductive circuit, power for average power is equal to 0. Okay, now we are going to consider Vi relationship of a capacitive circuit. Okay, so consider a capacitor in which is connected with a supply voltage, AC supply voltage V of t is equal to Vm sin omega t. ഇനി നമ്മൾ current relation എങ്ങനെയാണെന്ന് നോക്കണം. Okay, so the capacitor, AC through a pure capacitor, when an alternating voltage is applied to the plates, these capacitor plates, what happened? The capacitor is charged first. Capacitor നമ്മൾ electrical energy store ചെയ്ത് വെക്കുകയാണ് ചെയ്യുക. First it charges in one direction, then it discharges in opposite direction, then in the opposite direction. അങ്ങനെയാണ് സംഭവിക്കുന്നത്. അതൊരു alternating sinusoidal waveform ആയിട്ട് തന്നെയാണ് അത് ചാർജ് ചെയ്യുന്നത്. So when taken as V as the this V is the potential difference developed between plates at any particular instant, and when charges Q is represented as charge in plates at that instant. So we can write Q, charge on a capacitor is equal to CV എന്ന് എഴുതാം. നമ്മൾ പഠിച്ചിട്ടുണ്ട് ഒരു കപ്പാസിറ്ററിന്റെ ഇക്വേഷൻ, ചാർജിന്റെ ഇക്വേഷൻ is equal to capacitance in C is the capacitance. അതുപോലെ എല്ലാത്തിന്റെയും യൂണിറ്റ് നിങ്ങൾ അറിഞ്ഞിരിക്കണം. For a resistor, resistance is unit is represented as ohm, and for inductor, inductance unit is represented as Henry. H represent Henry ആണ്. And for capacitor, the property is capacitance, which is represented the unit as farad. Okay, so Q is equal to CV, where C is the capacitance. Okay, so we can represent this voltage as C into Vm sin omega t. We can represent this as C into Vm sin omega t. Okay, Now the current is given by the current flowing through this capacitor is given by the rate of change of charge. So we can represent this current as dq by dt, rate of change of charge in a current. So we can represent it as d by dt of cv sin omega t, cvm sin omega t. We substitute the equation for q as c into vm sin omega t. So c into vm sin omega t. Okay. So from this d by dt of sin omega t edka, so omega sin omega t edka, omega c vm cos omega t, cos omega t, differential of sin omega t is omega cos omega t. So we can represent this vm constant term namukku vm by 1 by omega c edala, omega c. Okay, so this is the term as capacitive reactance. So we taken it on the denominator and cos omega t. Okay. ഇനി നമുക്ക് എന്ത് ചെയ്യണം, ഈ equation in terms of sinusoidal waveform ആയിട്ട് represent ചെയ്യണമെങ്കിൽ we have to change this cos into sin. So how cos omega t can be changed into sin omega t? Sin omega t plus pi by 2. So Vm divided by 1 by omega c, then cos omega t എന്ന് പറയുന്നത് എന്താവും, sin omega t plus pi by 2. Okay. So we can write this equation as ഈ 1 by omega c എന്ന് പറയുന്നത് എന്താണ്, we can represent it as capacitive reactance as Xc. Represent it as Xc. Xc is the capacitive reactance. So X is equal to 1 by omega c. Okay. And c is the capacitance in farad, omega in radians. Okay. So we can write the equation as I of t is equal to I of t is equal to Im is Vm by 1 by omega c, Im sin omega t plus pi by 2. അല്ലേ, അങ്ങനെയല്ല നമുക്ക് ഇക്വേഷൻ കിട്ടിയ. സോ നമുക്കറിയാം our reference wave V of t is equal to Vm sin omega t. So what is the angular difference between, phase difference between voltage and current? Voltage is the reference, plus pi by 2 means it is a leading angle. So the current leads by voltage by pi by 2. Where Im, you remember Im is equal to Vm by 1 by omega c or Vm by Xc. Xc is the capacitive reactance. Okay. So we can represent it as a waveform, that is voltage and current relationship as a waveform. Voltage wave is taken as reference with respect to time, voltage and current relationship. So this is V of t. And take the current wave. Current wave is leading. Leading means it starts, or leading waveform we represent left side. Okay. So it's leading by pi by 2, minus pi by 2 minus origin starting. So it starts like this. Current waveform is leading by pi by 2. So this is I of t. Okay. So the current vector leads the voltage by pi by 2 in pure capacitive circuit. Okay. And here we can represent this as a phasor diagram. Phasor diagram representation can be just voltage is taken as, okay, this is V of t. Voltage is taken as reference. The leading vector can be represented in anti-clockwise direction. So take, this is your current vector. Okay. So current vector is I of t. I of t which leads voltage by 90 degrees. Okay, so we can represent voltage and current phasor like this. This is the phase. And Here also the power in this circuit is the average power of a whole cycle is equal to 0. So average demand of power from the supply is 0 in a purely capacitive circuit, same as in a purely inductive circuit. But instantaneous value of power can be represented as P is equal to Vm Im by 2. Maximum instantaneous value of power is Vm Im by 2, but average power is equal to 0 in a pure capacitive circuit. Okay. Now consider some equations. Consider the equation, and also you have to find out some values, some numerical problems. I will explain some numerical problems. First consider ഒരു പ്യുവർ റെസിസ്റ്റീവ് സർക്യൂട്ടിൽ നിങ്ങൾക്ക് ഒരു ക്വസ്റ്റ്യൻ തരുവാണ്. അങ്ങനെ ഓക്കെ, ക്വസ്റ്റ്യൻ ആയിട്ട് പറയുന്നില്ല, എഴുതുന്നില്ല, ജസ്റ്റ് വരച്ച് കാണിക്കാം. Some values will be given in this. In the question it is given that peak value of voltage is equal to 20 volt and the resistance value is 2 kilo ohm, and you have to find out. So you find out കണ്ടുപിടിക്കേണ്ടത് RMS value of current. So it is represented as IRMS, average value of current, then peak value is given. So peak value of voltage is given. So peak value of current and peak to peak value of current, that is represented as IPP. So RMS value of current, average value of current, peak value of current, peak to peak value of current. ഇത്രയും values കണ്ടുപിടിക്കണം. So given the circuit, you have to find out these values. Okay. So how can you, the given value, first you write the given data. The peak value is given as 20 volt. Okay. Then how can you find out the instantaneous value of current? I of t. You know the equation for a pure resistive circuit. I of t is equal to that V of t by resistance value, V of t by R, or we can write it as Vm sin omega t by R എന്ന് എഴുതാലോ. So you have given the Vm value, that is 20 volt, 20 into sin omega t divided by R. R is given as 2 kilo ohm. So you can write kilo ohm into ohm. You have to convert 2 kilo ohm into ohm. Kilo ohm in ohm load convert and you just multiply with 10 raised to 3. Okay. So I of t kandupidikalo idinnu. So you will get 10 into 10 raised to minus 3 sin omega t. This is the value for I of t. Then from this you will get the value of maximum current Im as or I peak value. I peak is equal to 10 into 10 raised to minus 3 ampere, or you can write it as 10 milliampere. Okay, this is the peak value of current. So you got this value. And what will be the peak to peak value? Peak to peak value. അതായത് നമ്മളിപ്പോൾ ഒരു വേവ് ഫോം റെപ്രസെന്റ് ചെയ്യുവാണെങ്കിൽ this is the peak value, this magnitude. Peak to peak എന്ന് പറയുമ്പോൾ അതിന്റെ ഡബിൾ അല്ലേ വരിക. പോസിറ്റീവ് പീക്ക് ടു നെഗറ്റീവ് പീക്ക് ആണ്. ഈ ഒരു വാല്യൂ ആണ് കണ്ടുപിടിക്കുന്നത് പീക്ക് ടു പീക്ക് എന്ന് പറയുമ്പോൾ. പോസിറ്റീവ് പീക്ക് ടു നെഗറ്റീവ്. സോ 2 into Im ആണ് ചെയ്യേണ്ടത്. So that will be 20 milliampere. Okay, 20 milliampere. Now you have to find out IRMS. IRMS ന്റെ equation എന്താണ്? Im by root 2. Im by root 2. RMS value of root mean square value അല്ലേ. So maximum value of current by root 2 ചെയ്യാം. So you will get Im the value നമുക്കറിയാലോ 10 into 10 raised to minus 3. So divided by root 2 ചെയ്യുമ്പോൾ it will be 7.07 into 10 raised to minus 3 ampere. Okay. ഇനി average value ഒരു equation ഉണ്ട് for a sinusoidal waveform 2Im by pi is the average value. നമ്മൾ ഇതിന്റെ derivation ഒക്കെ പഠിച്ചിട്ടുണ്ട്. So you should know this equation 2Im by pi. So you will get it as 6. Substitute the value of Im here, 6.36 into 10 raised to minus 3 newton. Okay. യൂണിറ്റ് എഴുതണം ആംപിയർ, കറണ്ട് ആണെങ്കിൽ ആംപിയർ. ഒരു പ്രോബ്ലം കിട്ടിയ എപ്പോഴും ആൻസർ കണ്ടുപിടിച്ച് കഴിഞ്ഞാൽ അതിൻ്റെ കൂടെ അതിൻ്റെ യൂണിറ്റ്സ് എഴുതാൻ മറക്കരുത്. ഓക്കെ, സോ ദിസ് ഇസ് ദ ഫസ്റ്റ് ക്വസ്റ്റ്യൻ ആൻസർ. സോ യു ഹാവ് ഫൈൻഡ് ഔട്ട് RMS value, average value, peak value, peak to peak value. Okay. Now the next question is, you have given a inductive circuit. Okay. And the voltage is applied. The value of, here you have given the inductance value 2 millihenry is given, and the voltage is given as, the RMS value is given as 10 volt. The RMS is equal to 10 volt, which is given as 10 volt, and the frequency is given as, F is given as 3 kilohertz. Okay. ഈ ഹേർട്സിൽ മില്ലി ഹെൻറി ഒക്കെ തന്നു കഴിഞ്ഞാൽ ഹെൻറിയിലോട്ട് കൺവേർട്ട് ചെയ്യണം. അതുപോലെ കിലോ ഹേർട്സിന് തന്നു കഴിഞ്ഞാൽ അതിനെ ഹേർട്സിലോട്ട് കൺവേർട്ട് ചെയ്യണമെന്ന് ഓർക്കണം. യു ഹാവ് ടു ഫൈൻഡ് ഔട്ട്, ക്വസ്റ്റ്യൻ ഇസ് ഫൈൻഡ് ഔട്ട് ഇൻഡക്റ്റീവ് റിയാക്ടൻസ് XL ആൻഡ് RMS വാല്യൂ ഓഫ് കറണ്ട് IRMS. ഇത്രയും രണ്ടുമാണ് കണ്ടുപിടിക്കേണ്ടത്. ഫൈൻഡ് ഔട്ട് XL ആൻഡ് IRMS. ഓക്കെ, അപ്പോൾ എന്താണ് നമുക്കറിയാലോ, നമ്മൾ ഡിറൈവ് ചെയ്തപ്പോൾ പഠിച്ചിട്ടുണ്ട്. ഇക്വേഷൻ ഫോർ ഇൻഡക്റ്റീവ് റിയാക്ടൻസ് XL ഇസ് ഈക്വൽ ടു L ഇൻറ്റു ഒമേഗ. ഒമേഗ ഇസ് ഈക്വൽ ടു 2πf. സോ 2πf ഇൻറ്റു L എന്നാണ് ഇക്വേഷൻ. സോ യു ക്യാൻ സബ്സ്റ്റിറ്റ്യൂട്ട് ദിസ്. 2 into pi is 3.14, or written it as pi, and F is given as 3 kilohertz. So 3 into 10 raised to 3 എന്ന് എടുക്കണം, kilohertz ലോട്ട് convert ചെയ്യാം. And L is given as 2 millihenry. So 10 raised to minus 3. 2 into 10 raised to minus 3. So you will get the value by substituting this or calculating it, is something 37.68 ohm കിട്ടും. Now you got the inductive reactance value. Now IRMS is, you can find out by VRMS by XL. V by inductive reactance will give you the RMS value of current. So you substitute the value, VRMS as 10 volt and XL you have find out now 37.68. That is, XL is a reactance, so you written it as unit as ohm. Here IRMS, so the value is 0.265 ampere. Okay, so you have find out these two values. And the next problem, just consider a capacitive circuit with a sinusoidal waveform applied across it, and VRMS is given. VRMS is 5 and capacitance is given as 0.01 microfarad. Okay, find the, and frequency is also given. Frequency is equal to 2 kilohertz. This is the given value in the question. And find out in capacitive reactance XC കണ്ടുപിടിക്കണം. Then RMS value of current. Find out in capacitive reactance XC. We know the equation for XC as 1 by C omega. That is 1 by 2 pi f C. So substitute the value 1 by 2 pi into frequency is given as 2 kilohertz. 2 into 10 raised to 3 and given as microfarad. Capacitance C is given as in microfarad, 0.01 into microfarad load convert in 10 raised to minus 6. So 0.01 into 10 raised to minus 6. It will substitute here. So you will get the value as 6.28 into 10 raised to minus 4. Like this is an ohm. Capacitive reactance in ohm. And IRMS is find out by this Vrms by voltage by capacitive reactance. Vrms by Xc. So you can find out it by Vrms is given as 5 volt divided by Xc is given as 6.28 into 10 raised to minus 4. Okay. Sorry, this value allato. ചെറിയ mistake പറ്റിയിട്ടുണ്ട്. ഇതിന്റെ value just calculate this as value as 7.9 kilo ohm ആണ് ട്ടോ കിട്ടുക. ഇവിടെ value 7.9 kilo ohm and you substitute this 7.9 kilo ohm here, so you will get the value as 6.28 into 10 raised to minus 4 as current ampere. Okay, ഞാൻ എഴുതിയ value തെറ്റിപ്പോയതാണ് question നോക്കിയപ്പോൾ. So Xc is fine. By substituting the value, just calculate it as 7.9 kilo ohm ആണ് കിട്ടുക. Then Irms is equal to 7.9. Just change the value. Sorry. Okay. So ഇതുപോലെയുള്ള simple problems ടെക്സ്റ്റിൽ ഉണ്ടായിരിക്കും. Just do it. Find out the values. Maybe 1 mark questions ഒക്കെ ആയിട്ട് ചോദിക്കാൻ chance ഉണ്ട്. Okay. Simple ആണ്. So in the next class we will study some series connections. അതായത് resistance. Now we have considered only the circuit with resistance only, inductance only or capacitance only. In the next class we are going to consider resistance and inductance in connected in series or അതായത് RL circuit or RC circuit or RLC circuit. അതാണ് അടുത്ത ക്ലാസ്സിൽ എടുക്കുക. Okay, thank you.